Hello everyone, welcome back to Munro Live. I'm Kevin, and behind me we have the 2025 Chevy Equinox EV. So kind of excited to see this because it's kind of like the first wave of GM vehicles that we have seen here. We've had a chance to look at a Hummer EV in the past and kind of poke around with some of them in a more limited capacity, but sometimes those vehicles and how they come in, their focus set is a little bit narrower. But so this is the first time I've seen it. It's pretty nice. The color is nice, all that stuff. From what we can see from the front end, and then we'll kind of start from the front, work our way back. But this is built on the GM's BEV3 platform, also shared with, in some respects, the Honda Prologue as well. From what we can see here, it's a little difficult to tell for sure, but looks like we have lower AGS as well coming through. You can see this kind of flat space here where they're packaging some, or at least protecting for packaging for an ADAS sensor suite. As we come down and underneath the vehicle, or actually even before that, just a small comment. So, headlights and DRLs being completely disassociated. This is kind of just a trend that we have been seeing in general. I don't know if that's kind of start to disassociate and get headlights a little bit lower and kind of address some of the concerns about, safety and some of the new headlights, and then just draw a lot of attention to the daytime running lights and the style that you see, a lot of OEMs trying to bring to the vehicles to see them, or at least make them very notable, at a distance as you kind of drive up or see the vehicles. As we come underneath the vehicle, you can kind of see it's relatively exposed here. We have, the aero shields off, which is a large, just injection molded aero shield itself. And, we can see that kind of complements this front lower piece of the fascia. There's a large, I would say it's probably a mandrel bent, lower impact structure with crush cans on either side that kind of complement and piggyback right up to the front end of the cradle itself. You can see the pedestrian speaker here since it's an EV. This is something that we see, it depends, sometimes OEMs will split structure and they'll do a lot of the lower structure for curb impact and pedestrian considerations. And then frankly, when it runs cross car like this, it helps in many of the major front end, crash events as well. Just kind of lightly pull this in, you can see what we can see here. So this member, comes across and it goes pretty far outward, roughly this probably just slightly inboard, maybe 25 millimeters or so of the wheel envelope, at least the initial part of it. And it's difficult to see, but there's a series of weldments there in the end, which makes sense, right? So small overlap, that 25% offset from your outer flange here. And this is kind of that whole, zone for small overlap rigid barrier, test countermeasures. We can see a slightly splayed engine bay rail as well, with an end cap where you have the mounting provisions for the stamped bumper. So I don't see any aluminum in any of the front impact structure. Looks like primarily all stamped steel. And the rail does slightly splay outward. So it looks like there's just kind of a gentle splaying out. And then once we get roughly, we'll say kind of near this front threshold here of the cradle, it does start to move outward and then grow in section, notably outboard. It's been a little while, but the old Chevrolet Bolt had this kind of cool 3 crush can array in the front. So I had the primary one and then another offshoot and then another for SORB. And then that changed in the second generation as well. So it's been interesting to see just how vehicles and specifically GM has evolved over time. And I'm happy to kind of see this because we've looked at a lot of stuff in the past. A big Mustang guy, but we had a chance to go through a Camaro. Very cool to see just how, in many ways, GM looking to some of the Pacific OEMs with castellation and skeletonization or scalloping of panels. And there is some here, and hopefully I'll get a chance to kind of point out where you see some of that, where helps with panel nesting, panel clearance, and drainage and stuff like that. And then just weight. When you scallop all those panels out, you cut weight out of the vehicle as well. So little things like that, I always found very interesting. A lot of smaller panels led to very efficient and strong body structure for the Alfa Camaros and Cadillacs. So, and as I kind of mentioned, the Prologue is similar to this vehicle, and I have had chance to take a look at it, very, very briefly. But it's very interesting to see that essentially the cradles are completely different between the two vehicles. When we look here, you have this kind of nice long series of stamping, big clamshell, relatively straight, pretty efficient for material utilization, welded over. I'm not seeing any other segments, but you do see like through here, there's piercings where they're doing welded joints for either reinforcement or to get the rails to kind of crush, or the cradle to crush a certain particular way. And you can kind of see that on top. There's like a bird's beak feature that complements the reinforcement that's welded here. But I kind of find this whole zone relatively interesting because it is very, very different from the Prologue, and it kind of speaks to each, although on a similar core nature of the BEV platform being shared with the Ultium, both OEMs go in a kind of a different direction. So there's this, steel tube here that welds and goes all the way up through. And if you want to come over and kind of take a look up this way, Eric, you can see it's a large multi-piece weldment stanchion. So this is just, no stamping here, just, bought tube, if you will. It runs up and ties into another complementary structure where the engine mounts are piggyback off of. But you can kind of see the layering that they're building up around this area. This section of the cradle comes out and terminates here, excuse me. And then another clamshell weldment is being built off of this to kind of get that offset needed for SORB. And then they have this crush can mounting point, again, scallop flanges to get rid of all the weight. You end up with a large panel for blanking, but it helps you because you really don't need, you just need the mounting surface for your fasteners, and it cuts off all the excess weight. But where, if I remember correctly on the Prologue, I think there was one less weld joint and this whole structure moved and jutted outward. And very similar strategy for the cooling module being supported right here with this kind of stamped offset piece, but it was a little bit more straight and running straight forward coming off, if I recall correctly. But one thing that's kind of interesting here, so you see the thickness here roughly, I don't know, that's probably like 2 and some 2.2, roughly equal millimeters, thickness here. And instead of continuing this stamping outward, which would have been relatively easy, and then using the draw that it already has, they decided very deliberately to stop that short and stamp a separate piece and weld that in. So that could speak to essentially just being relatively, just maybe mild steel, and then a higher grade here, or they're trying to get it to do something very, very particular. But it's a very deliberate decision on the part of GM to do that. So I don't know exactly why, but things like that I kind of key into, because you could have extended that, paid the material burden, whatever that is, but they may have run the numbers and felt that a separate tool, a separate part, and just a lower gauge material, and then paying for all the welding operations was worth it. Or there's something else going on that drove them into that. So little things like that I do find interesting. They kind of tell a story. And unless you were there kind of developing the front end, you wouldn't know it. So when you look at the cradle again, it's very linear, and it runs all the way back, actually right up into the battery pack, which is what we'll get to, but is definitely unique. So, relatively straight box structure. We have two, probably commodity pumps here, lots of nylon tubing and shielding. And most of the shielding runs essentially the entire length of the tubing itself. Now you can tape these, and what they've kind of done here, or zip tie, to shorten that length of run for the shielding itself, maybe be a little bit more efficient. But a lot of times, that costs more. So you think it'd be easier to just do like a short load and tape it or locate it in place. But if you're having a supplier built that, which is most of the stuff is, they don't want to deal with that either and try and locate it and make sure it's in the right spot. So a lot of times it's just easier just to shield the entire thing if you need the abrasion shielding, and versus trying to control it and be a little bit more efficient with its utilization. So 2 pumps here, you have the nylon lines, and then you can see here, maybe a little bit, this front upper cross member. Now the EDM is sitting on this, and it might be a little bit easier to see on the backside, Eric, if we come back around. And so lower front cross member, this upper bulkhead here for the front drive module, and then that stanchion that we were talking about, the sway bar mounts to it, and it runs cross car. But you can see the drive module mounts. So the fronts are polymer. And the rear are cast aluminum. Now, obviously, polymers are very strong. There's a lot you can do as far as material grades, thickness, and shape to get the strength that you need. I'd be curious to see if that's done for like NVH. Obviously the motor is rolling a particular way. At times, you can use different durometer bushings or different materials to get performance and locating one side of the joint, and enable maybe a higher level of NVH performance on the other side. But it is just noteworthy that they've done it in the front where it's a polymer, and on the back you can see coming through here right here as well. This rear mount, it's cast aluminum. So, I mean, just the, there's similar manufacturing processes as far as like, an additive perspective, but the dollar to kilogram ratio is probably more favorable on the composite side than the aluminum typically. But just another thing to kind of point out, which is interesting. So there's a lot of things that you can do, and there's a lot of flexibility with the polymers, especially for integrating certain things into it a little bit more easily than the cast aluminum at times, but more specifically, if you can get it to work, it's a little bit more cost advantageous. So we have the steering rack here. Nothing too crazy, but a lot of times you'll have, which this is done, the isolator is here, but these are running, forward in vehicle in the X direction. And this is kind of a clamshell, fastener where a lot of times racks will be oriented slightly differently, and then they'll run a fastener straight through into the cradle itself. So nothing too crazy, but it's a little different in execution than some of the other things that we see come through quite a bit. But this whole area here is a little more different. So as the cradle kind of comes rearward, it butts right up against essentially where this lower torque box area would be. It does have a torque box, but it's relatively shallow. As far as the Z height here, a lot of other vehicles, you have a much more pronounced box structure here and a lot more volume, where this is moving straight rearward. And you do kind of have, even the battery pack itself has this kind of offshoot for both decking, where they're locating both the cradle and to the body. And then there's decking points here to keep the battery pack nested with the body as well, as it's brought up. But, literally the cradle comes right up to the very edge of this structure. And then, the battery kind of tapers back probably another, 75 millimeters or so rearward in an X, but definitely unique. A lot of times there's a big air gap here, or you'll see, purposeful reinforcement. They're bringing this all the way back. We have a series of bolts and double shear plates to secure both the cradle and the battery kind of together with the body itself. And let's see here, I think I saw some. Yeah, here's kind of an example what I was speaking to earlier with the scalloping of the panels and the castellization. So both are done here. So you got a little bit of an air gap with the castellation on the backside, and then the scalloping done here. As long as you can essentially, these are pretty big weld flanges, at least in this area here, they start to taper and get a little bit more aggressive as far as size and location. But clearly, they're able to get their weld heads on here, no issues. But sometimes, people have struggled, or at least customers that we've had in the past have struggled when we've kind of suggested stuff like this, because it is free weight savings, where, their facility is just not capable of guaranteeing, placement at times. So, or there's some other things that just drive a consideration where they don't necessarily like to do that. But it is free weight, does kind of give some ability to shed moisture and water away from the body structure. And also, we're not really seeing an example of it here, except for right here, but allows for, at times, like different material stack ups where you're weaving various panels in together, and you're not necessarily always doing a 2 or 3T weld or thickness, right? So 2T here, this is a 3T up here, another 3T if there's no weld here, but through here, 2T, all the way through. So another advantage of scalloping, where you can start overlaying panels together, and if your weld cell, for whatever reason, is not capable, or you don't want to do it from that joint, it does give you the flexibility of just doing 2T joints all the way through. So I don't want to miss the suspension itself. We kind of went straight back through for the rail, just given the construction of the lower cradle. So a nice simple U-shaped stamping here. It kind of flares out, goes to the top of the rail. So it is flanking over and sleeving over the rail itself. It's a McPherson front strut. We have a cast knuckle, pretty simple, just a nice clamshell weldment. Kind of comes to the edge here, and then we have a relatively large kind of handoff here for the bushing, and then some provisions on a vehicle that this is actually just the front wheel drive vehicle itself, and likely doesn't have any other ride height sensors or any other provisions, but that's typically what these bolt socket joints are for, is a ride height sensor. But as you can see, it's a McPherson front strut, runs all the way up. So very simple, very effective as far as managing cost and performing, well. 911s are a little bit different, but they're still McPherson front strut as well. So, but yeah, as you kind of look through, we have a bolt-on lower ball joint as well. And it'd be interesting to see, they have made a decision to do aluminum here, if that is part of a crash grip or not. Obviously it's a little bit higher cost, or it could be the shape itself where they would struggle on another material to get what they're looking for. But anytime I see kind of dissimilar materials bolted together, there's always typically a story for what is going on there, and it's just kind of an interesting point of note. As we move kind of more rearward in the vehicle itself, and I would like to kind of look back up through here, Eric, and take a look. So in the front of the cradle, we had kind of this lower plane here, and then there's the upper, drive module mount. You can see the EDM here. The inverter is packaged above it. I imagine it's probably very similar to the Hummer EV that we looked at, just everything being downsized. Even when you look at essentially on the gearbox here on the bottom, where your gear set would be, and they essentially have this bulkhead that runs in between them to help locate the gear set on one side and your rotor stator assembly. Where not everyone does that, but it is something that helps, I think, from a build process standpoint. While you end up with an extra set of gaskets, it does help locate, essentially all the internals of your drive module. And it's obviously a deliberate decision by them to implement it. But this looks similar as far as its overall layout of components to the Hummer, and makes sense, right? They're probably just scaling a similar execution all the way up through their desired power output range and vehicle platform. So the battery pack itself here, so you have your high voltage connectors in the front and the cooling. Again, there's from what I saw, right? So right here, this is essentially where all the aero shield mounts. I've kind of made comments about this before. Last time we had the Wagoneer S, so all those edges were rolled, very well protected. Granted, it is a Jeep. It's a little bit different than this, but and you do have this essentially cradle being slightly lower in Z from this plane to help protect it. But I always feel it's just interesting to see how often the high voltage stuff is just kind of hanging out. I just recently drove up from Camp Atterbury with all those storms, and there was debris all over the roads, and just always in the back of my mind, I kind of think about just impingement and things coming up and hitting the vehicle. I have a little bit more of an off-roading mindset with some of that stuff, so this is probably fine. There's a whole series of test evaluations that these vehicles go through. I just find it interesting when and where OEMs decide to essentially provide additional protection or routing provisions for high voltage connectors at the front of their packs. So as we kind of move rearward in the vehicle itself, it's a large stamped steel battery tray. It's, I believe this one is 85 kilowatt hours. And instead of it being like a large, big piece of, a large just single stamping, it appears that everything here is segmented together. So they are welding and then sealing, all the provisions within the pack. It's difficult to know for sure. These outer stampings are a little bit different, but it does kind of give you the flexibility of changing some provisions here. But these inner stampings here within the battery pack appear to be common. It is something we kind of saw with even the Hummer, a lot of small stampings, a lot of parts, but there is something to be said on the positive side where you can do a lot essentially of family parts and get the volume for those parts really high, which oftentimes is very, financially valuable, right? To get the volume high, use those parts, and then deal with the welding, operations or assembly operations to keep the piece price and the material price as low as possible. So that kind of seems to be what they're doing here as far as segmenting this pack together and giving them the flexibility to swap out either the inner structure that's here, and I haven't seen, either this or a Prelude or anything like that, or a Prologue, excuse me, from the inside. So it's a little hard to tell, but it's at least doubled up from what we can see with these kind of small hat sections running around. And if you want to come back here, Eric, and take a look, you can see a depression here. I'm not even sure what type of cell arrangement that they have, but they are obviously nested in these panels, and there might be a lot of 4-aft structure, running forward here, part of their cooling plates. But overall, it's relatively flat, and then essentially relies, again, heavily on stampings. And even when you look here at the outer interface, a series of, I don't know if these are nope, these are stampings, brought here to kind of give you that section needed to complement the rockers as it runs down, and then they're kind of closing out the gap between the outer edge here of these stampings and the battery itself. As more move a little bit more rearward, we have essentially a relatively conventional 5-link in the rear. Again, I want to say the Prologue, a little different in the rear. So these are most certainly hydroform sections coming through here. I want to say that the Prologue was 2 stamped clamshells in the rear. And we've kind of done some exercises like this to see cost and what is more advantageous. It is hard to beat tubes, right? No extra flanges, no extra welding ops. You are pre-bending them and then throwing them in in some ways a press, right, for lack of a better term, and then pressurizing the tube and then filling that void. But just an interesting point to note that, again, while they are on similar architectures, GM is doing a hydroforming setup, and the Honda is clamshell. So you can see the rear end here, the battery pack as well. Some just tie-ins to run up and stabilize the aero shields that have been taken off. And we get to see kind of, there's an area here or a volume for, if they needed, I guess you could have kind of a penthouse, but when you look at where the brake routing is, and granted this is a particular variant, and they may do different brakes for different vehicles if they use that space, but there is a relatively large amount of volume that is still open on the vehicle itself there. So a small sway bar running across, 2 fasteners. I'd love to see more people do kind of like it really depends on the material and the joint that you need, but we have seen in the past where this would be kind of like a tabbed interface on one side and just a single fastener. Or again, people that have captivated these with an existing structure elsewhere between the vehicle itself. But let's see, there's also kind of an interesting provision, a little difficult to see with this aero shield still in place here, but you can see one of the large mounts here for the front end of the cradle going up the isolator, big double shear plate, and then essentially the end of this tube gets significantly reduced, which is one of the benefits of hydroforming. You can play around essentially with the diameter, but you got to manage it. So if it's a 5-inch tube, when you get down to packaging constraints like this, you got to flatten the end of that tube or fold it kind of back in on itself within reason. There's parameters, right, of how much you can move that tube through various swept sections, but it's kind of interesting to see how they've kind of packaged it and pushed that material outward, and you can kind of see this is the area that it lives in. So it is relatively large, just given the section size of the tube. The multi-link, we have, looks like almost everything is, besides the actually this might be, oh, this is welded. Most of these are just single ply stampings, a good, nice, straight, efficient runs. Ideally, that's pretty much what you want. And these are just really kind of tall hat sections to get the rigidity that they need, through it. And just the camper link, at the top is a forging, but and you can see the kind of real aggressive kink here to package. You can see how large the section of the rail is here. They get it up and around, and obviously we're full droop. So when this is sitting in a nominal position, it's much closer to the rail itself. You kind of have your clamp saw section here that kind of sleeves over the rear bulkhead. When you look at the empty volume here, so these are available in all-wheel drive, obviously biasing the front because the amount of space here to package is significantly smaller than what we have in the front available. So it's more of like a helper motor, which is not uncommon in general, right? Even with your ICE vehicles, a lot of the kind of vehicles in this segment are all-wheel drive, and they're running a PTO or power takeoff unit running back with a prop shaft and just a small differential. That when you look at like overall ring gear sizes, everything, since it is front-wheel drive biasing, significantly larger in size than the rear here because it's not necessarily applying power in all situations. It's just helping to add traction versus deliver total power of the vehicle itself. Let's see. Overall, right, it's, we kind of have a disassociated dampener and coil going right up into the rail, so very efficient as far as like the packaging, and it kind of moves right into a cross car like member, so that whole there's like a rear cross member coming across the back here in the trunk, and then it kind of flares out, and they kind of use this area anyway, which typically you'd like to have some transitions smooth out with any of this structure for impact and just general load transfer, and they're kind of complementing that. And you can see as it runs outward into the rear rail heel, so they're just piggybacking off of what they want to do with this structure anyway. So it's a good use of the material and kind of how it packages and where these loads want to go in the vehicle. Let's see here. We kind of spoke a little bit, like here you have a joint for a series of brake lines. Oof, got a little dirt in my eye, sorry. Coming up and over, and it's running down to the back here. This is, let's see, kind of interesting. So not running down the cradle, it's coming back along essentially what would be the spare tire well, and then running outwards. And they do have provisions, it looks like, for another one to run on each side, or it just is just a common joint, so it's got a living hinge and snaps on itself, and it pushes over, it looks like it's pushing over just a projection weld stud, which is cool. It is noteworthy that it's, in part probably because it's an isolated cradle, but it's kind of disassociated and running out the sides, and then coming back to the lines and then down. I don't see too often brake lines running past essentially like a point of where they want to be and then coming down and running out. Not necessarily anything wrong with it. It's just definitely unique. So I'm really curious to see what drove them to decide to do that. But overall, it's kind of exactly what I expected to see for its price class. That starts at I think $35,000 and it kind of works its way up. So when you kind of look under here, very similar to, we've seen a lot of Hyundai Kias here, and they kind of have a similar material layout and suspension layout. Oftentimes a little bit simpler, in the back. So the fact it does have a multi-link in the rear is nice from like a driving dynamics perspective. But overall, I think it's an interesting offering, and I don't know if we'll ever tear one down, but I would like to see more. Like when I kind of look through here, just everything about the size of that section, and you're sitting essentially in that area. There's a lot of strength there. When you look at just the layering of how everything is kind of you on top of you coming up here and running up. I'd like to dig into it a little bit more if I ever had the opportunity. One thing you can kind of see up here actually as well is some panel. This is just sealing out versus like a panel adhesive. So either done for NVH, sealing, water management, something to that effect. But you can kind of see how it's done here, and then all the shingling just cross car of the main cross member. Then there's another piece here, like a doubler almost, that doesn't go all the way up to the top. And then this piece here, which is gonna go blend into the rear rail here, just kind of wraps up and goes all the way to the top. So again, I kind of mentioned with like the Camaro and the Alpha platform, we saw smaller stampings, thinner gauges, and more assembly operations, but it does keep your capital investment low and allows you kind of stitch vehicles together and keep them pretty weight efficient. And from battery pack capacity and things of that nature, the weight matters. And we've always seen between Alpha, the Lambda, and a lot of the newer GM architectures, them being pretty weight efficient when you compare their body structures across the competitive set.
When you say 5 links, what are the 5 links?
So you got 1, 2, 3, 4, and 5 here. So they're controlling your various. They're essentially controlling the knuckle in space as it moves through. But that's essentially what it is. I'm not a chassis dynamics guy, but essentially this allows you to have pretty precise control. Like we mentioned, like with the McPherson front strut and the front McPherson front suspension. Not really a lot of camber change as the wheel travels. If it was a short long arm setup, essentially that upper arm would help drive or guide the knuckle like this camber arm would as it travels upward it's dictating its path as it moves in and bringing the tire in. This just helps give you more accesses to kind of control and place your tire in relation to various driving situations. So typically speaking, it's a more premium offering. Like you'll see, like on the Maverick or something like that, or even a lot of the earlier and older German cars, like a twist blade setup where you'd have a knuckle and then a large member, right, that kind of comes off, and then that is what's locating the axle or the knuckle, depending on what type of suspension style it is, and it's just controlling it with significantly less links. So. But yeah, I mean, overall, it's kind of exactly what I expected to see, underneath, aside from kind of the unique provisions we talked about in the front of the cradle, more specifically, how different the thinking of a different Honda, the Prologue and the Equinox are in the front end structure, and then even the rear cradle. Cradles seem to be, if I remember correctly, a little bit more similar in overall layout, but the fronts are very different. So that's kind of, very indicative of essentially what, certain OEMs, I don't want to say do or don't care about, but what each platform and their leadership is kind of driving towards and, trying to deliver the vehicle. So, well, overall, I appreciate you guys kind of coming back to the channel and taking a look at the Equinox. Hopefully we get to take a look at some more of the newer GM platforms. As more of a body structures guy, or more of my leaning, most of that stuff goes to. I've always really enjoyed having a chance to take a look at them. I think they're just how their overall construction is and just how competitive we've seen from a weight perspective. It's just a little bit different compared to the other, of the big three. A lot of their body structures are just, their overall layout is much different than the others. So it's always kind of interesting to have a chance to see. So thank you, and until next time.